Some people wonder, how did Einstein think? How do we physicists think? Most of it is when we're quiet, all by ourselves. We stare out the window and have blocks of equations just wandering in our head until these equations fit together, and then we get a sheet of paper and scribble.
It can be very frustrating at times, scribbling equations everywhere. The old cliche of scribbling on the back of the envelope often is true, because that's sometimes all you have around.
He was always thinking in pictures, visualizing things. When his father gave him a compass, he would just sit up night after night watching the needle point northward. It would send chills down his spine.
Einstein once said, "I want to know God's thoughts in a mathematical way." Einstein wanted an equation, perhaps no more than 1 inch long, that would encapsulate all physical laws. The beauty, the majesty, the power of the universe into a single equation. That was his life's goal.
In 1900, Albert Einstein is a 21-year-old undergraduate at the Swiss Federal Polytechnic. That this young man will one day be synonymous with genius was something none of his professors would have predicted.
He would cut class. The professors thought he was a goof-off. As a consequence, Einstein couldn't get a single job after graduation. He even thought about switching fields and selling insurance. Can you imagine opening the door one day and there's Albert Einstein selling you life insurance? What a waste. Einstein thought he was such a loser. He wrote a letter to his family saying that it would be better if perhaps he was never born. Nobody was talking about the young Albert Einstein.
He worked as a substitute teacher in short jobs in various towns. Einstein's father tried to apply on behalf of Einstein for academic positions. And he wrote to a very famous professor and asked him whether he could use Einstein as a research assistant. But there were no positions available.
His father passes away, thinking that young Albert is a total disgrace to the family.
In 1902, the depressed and despondent young Albert moves to Bern, Switzerland's capital, and begins a career far from science.
One of his friends arranged for Einstein to get a job as a lowly patent clerk in the Swiss patent office.
In this office, on the 3rd floor, Einstein spends 6 days a week reviewing applications submitted by all kinds of inventors to the Swiss government.
Given a patent, you had all this information, and he had to strip it down to the essence, and that honed his skills as a physicist. He would very quickly dash off all the patents that he had to analyze.
He didn't find the work very strenuous. It was not so intellectually demanding.
And it would give him ample time to contemplate the universe.
He never would have been very good at a university kissing up to a senior professor. He was much better at a stool in the patent office, trying to daydream about what is it like to ride alongside a light beam.
From that job, he would launch a revolution which would change world history.
Einstein's idle daydreams will profoundly change the way the universe is understood. In 1905, in what's been called his miracle year, he publishes in his spare time 4 visionary papers, the first of which answers the age-old question, what is light?
The photoelectric effect. This paper, written by this total unknown, showed that light comes as a particle called the photon. We use that in television, we use that in lasers.
In another paper, the 26-year-old Einstein posits something we now take for granted, the existence of atoms.
People didn't believe in atoms in those days, but he proved that atoms can actually make small little dust particles move in a liquid. And he calculated the size of atoms.
These papers would have been a remarkable career for any physicist, but Einstein is far from finished.
He writes yet another paper with the famous equation E equals mc squared.
At the simplest level, this means energy can become matter, and matter can become energy. The tiniest speck of matter holds potentially huge amounts of energy. Unleashing it requires a nuclear reaction, the sort going on constantly in the night sky.
Ever since people began to look up in the heavens, they would say, what makes the stars shine? But it took Albert Einstein to answer the question. Mass, M, turns into E, energy. That is the engine that lights up the stars.
Today, E equals mc squared is Einstein's most famous equation. But another theory he publishes this same year is more important and more controversial: the special theory of relativity. When Einstein was a teenager, he enjoyed imagining what it would be like to ride a beam of light. Now, he returns to this daydream, and it changes his life.
In the spring of 1905, Einstein was riding on a bus, and he looked back at the famous clock tower that dominates Bern, Switzerland. And then he imagined, what happens if that bus were racing near the speed of light?
In his imagination, Einstein looks back at the clock tower, and what he sees is astonishing. As he reaches the speed of light, the hands of the clock appear frozen in time.
Einstein would later write, a storm broke in my mind. All of a sudden, everything kept gushing forward.
Einstein knows that back at the clock tower, time is passing normally. But on Einstein's light-speed bus, as he reaches the speed of light, the light from the clock can no longer catch up to him. The faster he races through space, the slower he moves through time. This insight sparks the birth of Einstein's special theory of relativity, which says that space and time are deeply connected. In fact, they are one and the same, a flexible fabric called space-time. Sitting alone on a city bus, Einstein believes he has glimpsed a secret of the universe.
For Einstein, space was this place where stuff was, and it didn't do anything. It had stuff in it. And so space combined with time to become space-time is a more dynamic understanding of this arena that everything takes place in. It's becoming more alive in a way. He's saying very, very outlandish and very, very strange things.
Rarely had anything so radical been submitted to Europe's most prestigious scientific journals.
He was a complete outsider to the physics of his day, as he was, being in Switzerland, being a patent clerk. And yet he was ambitious enough to think that he could challenge the whole of the established physics at the time.
You always hope that there will be total euphoria, that everybody will say this is a huge step forward in the subject. But that rarely happens.
Whatever one's concept of time, it passes slowly for Einstein at the patent office.
He submits papers to important scientific journals, the best scientific journals, and hopes for the best. And the best doesn't come for a while.
He was anxious. What was the reaction of the physics community to his great paper? Silence. Einstein got very depressed.
3, 4, 5 months must have felt like an eternity to him.
And then Einstein's papers fall into the hands of perhaps the one man who can fully understand him, Max Planck.
Max Planck is the greatest theoretical physicist in Europe.
Planck was the editor of the Annalen der Physik in Berlin.
The most important physics journal of the time.
Here was Max Planck reading this paper from this unknown physicist. And Max Planck says, there is something here.
Planck recognized immediately that this was an important paper from an important young scholar. The relativity paper was published in June 1905.
That volume, number 17, is now one of the most famous publications in the history of science. At the time, Einstein wasn't even a scientist.
He's still applying for jobs at colleges, high schools, always getting rejected.
We call it Einstein's miracle year. It is certainly not a time that he would describe himself as a miracle year. Miracles convey a sense of something happening easily.
I don't think that Planck knew that Einstein was a patent clerk of the third class. So he must have then become curious about who this unknown Albert Einstein in Bern was.
This unknown Einstein is in fact the father of a 1-year-old son and husband to a quiet and serious fellow student from the Swiss Polytechnic, Mileva Maric.
When he was at the Polytechnic in Zurich, he was quite a ladies' man. He would play his violin at ladies' luncheons and cocktail parties, so he knew quite a few young women in his day. But Mileva caught his eye.
Mileva is the only woman in the class.
Here was a physicist. He was smitten.
In a temporary detour from their shared scientific passions, Albert and Mileva are married in 1903. A year later, their first son, Hans Albert, is born. The Einstein family lives in this small 2-room apartment in the Swiss capital.
The rather limited circumstances in which they lived were not what he would have hoped for at this stage in his life.
Mileva had always wanted to be a great physicist, but she flunks her exams at the end of her terms at the Zurich Polytech. She becomes a sounding board on all the great miracle year papers of 1905, especially the special relativity paper. She helps type it up, she helps check the math, but she ends up being a housewife.
Einstein is trying to do his scientific work at the same time that he's working 6 days a week.
In 1907, Einstein agrees to write a new article explaining special relativity. But when he re-examines his theory, he finds it seriously limited.
It was called special relativity for a reason, and that was because it really only dealt with moving at constant speeds.
In other words, Einstein's special theory of relativity only applies to a special case, an object moving in one direction at a constant speed. But Einstein wants to understand the real world, and the real world doesn't work that way.
Einstein realized that his theory failed for accelerations. But in our universe, everything accelerates. On a bumpy road, jet airplanes, on a subway car, everything's accelerating. So there was a defect in special relativity.
On Einstein's imaginary journey, if his speed varies at all, his theory, his notion of how objects behave in time and space, falls apart.
His scientific mind wants it to apply to all cases.
Einstein knows that for his theory to work, it has to account for everything in the universe. And that includes the pervasive and invisible force that holds everything together.
Gravity. Gravity is everywhere. Gravity holds us to the floor. Gravity holds the sun together, the solar system together. Where was gravity in special relativity?
Einstein wants to expand his special theory of relativity into a general theory of relativity, a theory that will explain not just time, but also gravity. He realizes he will be fighting more than 2 centuries of scientific thought, and his hero, Sir Isaac Newton. It's 1907, and the 28-year-old Albert Einstein is still a patent office bureaucrat. It has been 2 years since he published his special theory of relativity, and the ambitious Einstein decides to advance an even more radical interpretation of the universe, a general theory of relativity. Doing this will require him to take on his scientific hero, Sir Isaac Newton.
In Einstein's time, Isaac Newton was God.
Newton was the founder of modern science. This is the actual first edition of Newton's Principia Mathematica of 1687. This priceless artifacts is the very, very famous book which became the foundation of universal physics for centuries, until Einstein upset the apple cart.
It has been almost 250 years since the apple fell from the legendary tree on Isaac Newton's estate, giving Newton the inspiration to formulate his law of gravity.
Newton said that if an object falls, it's because there's a mysterious force called gravity pulling it down. But you know, Isaac Newton himself was not satisfied by that. Objects move because they're pushed, not pulled. Objects move because they're pushed. So what is pushing this? Newton didn't know. So Newton simply threw his hands up and said, I don't know. So I'm going to invent something called gravitational pull. And Einstein said, no, this theory can't be right.
He was prepared to simply go, I really want to solve this problem. I want to really understand the whole universe.
Max Planck said to him, you can work on gravity if you want to, but there are two problems.
You're not going to be successful. The problem is too hard.
And if you do, no one will believe you.
It's an extremely difficult task. It's not clear where to begin or how to go about doing it at all. Ultimately, the thing that gives him that clue turns out to be his old faithful way of reasoning, the thought experiment.
It's what you and I would call daydreaming, but he gets to call them thought experiments because he's Einstein.
He's in his office at the patent office, looking out at the window, and he imagined a man working on a roof. And he begins to wonder what would happen if one of those men were to fall off the roof.
And then he had the happiest thought of his life, the inspiration of the ages.
He had a vision. The man will not actually be feeling his own weight.
He would be weightless. And then he imagined, if you're in an elevator and somebody cuts the cord, what happens to you? You fall. But the elevator falls at the same rate you do, so you are weightless inside the elevator. So then Einstein got it.
It's as though gravity's been switched off. What's really going on?
There is no such thing as gravitational pull. The Earth has curved the space around me, and space is pushing me into this chair. Space itself can be curved.
That's crazy sounding.
Space is adjustable.
It's actually malleable. Space and time are malleable.
It's this flexible thing that can be twisted.
You bring an object into space, and it distorts the space around it.
Why does the Earth go around the sun? Most people would say, well, the sun's gravity is yanking the Earth toward the sun in a circle. Wrong. The Earth is going around the sun because the sun has warped the space around the Earth, and space is pushing the Earth toward the sun. He had a new theory of gravity, a new theory of the universe.
Einstein publishes his ideas about gravity. At the same time, his work on the atom brings him increased attention. As a result, in 1911, he's offered a position as a full-time scientist at the University of Zurich. The 32-year-old patent clerk finally leaves Bern to become, for the first time, Professor Albert Einstein.
People start realizing that those miracle year papers of 1905 are probably right. And he starts getting invited to the Solvay conferences, which are the gatherings of the greatest physicists in Europe.
Convened by the Belgian philanthropist Ernest Solvay, these conferences bring together the greatest scientific minds in Europe, and Albert Einstein is among them. In fact, he's the youngest professor there.
He made an impression. He was friendly, he was funny, and he was smart, really smart, and people saw that.
That was also a moment when Mileva must have perceived that she was still part of this small Bern world, whereas Einstein had become part of a bigger world.
She writes these plaintive letters saying, tell me about it. I wish I were there. I would love to meet these great scientists. It was always my dream to meet these great scientists.
She became jealous of not only the other physicists, but of physics itself.
Einstein's lectures become the talk of scientific Europe, and he's invited to speak in Berlin, capital of the country in which he was born.
Berlin at the time was the most vibrant city in Central Europe.
Einstein hadn't been in Germany since he left at age 15 to avoid the draft. He renounced his German citizenship the next year.
While Einstein was in Berlin, mainly to visit colleagues, he was also invited by a cousin.
A first cousin named Elsa Einstein. They had known each other as kids, but Einstein had lost track of her.
Living on her own, had divorced, she had 2 daughters.
She's just the opposite of Mileva. She's not a scientist, she's not an intellectual, but she loves making big old dinners and taking care of Einstein.
They liked each other's company, taking long walks, looking at the boats, and he must have been fascinated by her. Einstein returns to Zurich. They exchange fiery love letters.
And at one point, it becomes so strong that Einstein says, please don't write me anymore. This isn't going to work.
He must have felt that this was an overcomplex situation, even for an Albert Einstein.
If the mysteries of the heart elude Einstein, the mysteries of the universe trouble him even more.
The curvature of space and warping of space-time, and you scratch your head.
He has now been struggling for 4 years to more fully develop his general theory of relativity.
His theory of relativity is so complicated that very few people can understand it.
Somebody's got to test it.
It's not a testable hypothesis. It's not science. It's science fiction.
Einstein knows he's on the right track towards solving his theory. Now he must find a way to prove it. It's 1911. For 4 frustrating years, Einstein has struggled to perfect his general theory of relativity. His theory won't be accepted until he can demonstrate this radical concept. Suddenly, he is struck by an idea. If he can shine a beam of light through an area where space is curved, then according to his theory, the beam of light will actually appear to bend.
Light only knows straight lines. What's bent is space.
What could have enough gravity to bend light so much? Well, what about the sun?
300,000 times more massive than the Earth, the sun is the perfect object for Einstein's experiment. But how can anyone shine a beam of light around the sun?
He says light from a distant star, as it passes right next to the sun, and the sun's gravitational field will be bent.
Because space is bent around the sun.
But even if Einstein is right, he'll never be able to see it happen because the sun is just too bright. Except,
when is the sun covered so that we can see what's around it without being blinded by the light? That only occurs during a total solar eclipse.
Here's the sun, and it's blocked by the moon, and suddenly all the stars come out. He figured if you have the sun here, and there's stars way back here, and the light's coming in toward you, it will bend slightly. So to your eye, you think that the stars had gone out like that.
Light going around the sun. That's something that even his mother could understand.
Nobody actually was willing to say without doubt, this is the truth, until somebody can prove it by taking a picture.
So who do you turn to? You turn to the astronomers, the astrophysicists. Our laboratory is the entire universe.
by 1912, Einstein believes he is finally on the verge of proving his long percolating and provocative theory.
He publishes this revolutionary prediction and puts the call out to the astronomy world. Go out and measure. He said, go to an eclipse and do this observation. Nothing happened.
He actually wrote to
well-known astronomers trying to interest them in doing a test, and was a little discouraged, I think, because he discovered, as people often do, that astronomers are busy people with many things to do and don't necessarily drop everything at the drop of a hat, even for Einstein.
It's a frustrating and bitter setback for Einstein. But then, at the Berlin Observatory, a young assistant answers the call. He's an impassioned and brazen young man who's willing to go, quite literally, to the ends of the earth for Einstein. His name is Erwin Finley Freundlich.
Freundlich was in his early 20s. He wanted to make a name for himself. He got a sense that here is my chance. This is new stuff, it's important stuff, and I could be part of it.
I've seen the letter that goes in the other direction from Einstein to Freundlich, and it's all filled with this excitement. You astronomers can do great help to me by finding proof of the relativity theory. And that's Einstein, the human being, who is trying to get somebody to do things for him because he needs him.
He finds out from Freundlich that he's getting married to his girlfriend, Katja. And they're going to honeymoon in the Alps. So Einstein says, come to Zurich and let's meet.
Freundlich is on his honeymoon with his bride, and he goes to meet Einstein.
He's looking for him out the window, and there he is. There's Einstein. He can recognize him because he's wearing this straw hat, and he's standing out like a sore thumb. And this is the famous Einstein that he's corresponding with this prediction and this great opportunity. And he's going to get to meet him. So he gets off the train and he shakes his hand and they're all animated. And before they can talk, they whisk the couple off the train and they go to Frauenfeld nearby. It's a suburb.
To their surprise, the newlyweds are spending their honeymoon in an auditorium, listening to Einstein speak.
And in the middle of the lecture, Einstein says, we need this eclipse test, and the man who's going to decide is sitting in the audience. His name's Erwin Freundlich, and there he is, and everyone looks, and Freundlich has to stand up and be recognized. And so Freundlich was thrilled, you know, this recognition at this great meeting. On the way back to Zurich, Einstein engages Freundlich in an intense discussion about gravitation while the new fiancée, Katja, just looks at the scenery.
They start hatching up that plan of going to a total solar eclipse.
The problem with the total solar eclipse, of course, is that it's only visible over a small area of the Earth because the shadow of the moon is actually only a few miles wide.
They get these tables and they realize that the next total solar eclipse will occur in the Crimea, which is in Russian territory, on the 21st of August, 1914.
Freundlich goes to his boss, says, look, let's go to Russia. I'm collaborating with Einstein. Will you put the money up? And he says, no way. He just refuses. Einstein is absolutely furious.
Reaching beyond the European scientific establishment, Freundlich writes to the director of the Lick Observatory near San Jose, California, a rugged outpost of American astronomy.
It was a community living on the mountain. They all had their families, their wives were there, their kids were there. They were depending on each other for survival. For many years, it had the largest refracting telescope in the world.
But most importantly, it has William Wallace Campbell, a pioneer of eclipse photography.
In the 19th century, eclipses used to be attended by astronomers who just did visual observations. I saw this, I saw that. They would draw diagrams, and if people disagreed, it was one guy's word over another. Photography meant you can actually capture what was happening and do precise measurements. Campbell pioneered that technique in the early 20th century. Freundlich writes a personal letter to Campbell. He says, there's going to be an eclipse in 1914. Why don't you come to Russia and let's do this? So there's this wonderful correspondence between Campbell and Freundlich, the senior doyen of California astronomy and this little pipsqueak of an assistant in Berlin who's doing this against the will of his boss.
They will be the first to either confirm or to discredit Einstein's new theory of gravity.
This was an important observation. Campbell had a fever in him. He saw fantastic opportunities for Lick Observatory and for America. And he says, I'm going to get this sucker. This is a tough problem, and I'm going to be the one to crack it.
Meanwhile, opportunity is knocking on Einstein's door. His original mentor, Max Planck, is asked by the King of Germany, Kaiser Wilhelm II, to recruit the best scientists for a new institution in Berlin. Planck recommends the young man he considers his own discovery, Albert Einstein.
And they said, if we bring Einstein here, people will look at this and say, Berlin is where the action is. It's worth whatever it takes to get him here.
On July 11th, 1913, two men arrive at the Zurich train station, Max Planck and Walter Nernst, a renowned German chemist. They are hoping that a personal appeal will persuade the rebellious young scientist to return to his German homeland.
Two men, middle-aged guys in dark clothes, get off the train, and they go find Einstein.
They're so different. Max Planck is very proper Prussian, always very well-dressed and well-groomed, wearing the monocle, talking in very formal tones. And there's Einstein, who's refusing, even back then, to comb his hair and dressed in, you know, sort of old coats and however he feels like it, already starting not to wear socks. They make a great offer to him. He'll be a professor at the University of Berlin. He'll be a member of the Prussian Academy. He won't really have to teach classes. He'll have all of the research help he needs.
It was Max Planck. It was Nernst. It was the Prussian Academy of Sciences. It was the entire world of physics that had said no, bearing down and saying, we want you. Einstein did not answer the offer.
Einstein says, why don't you just go take a trip for the rest of the afternoon up the mountain?
I said, I'll meet you at the train station when you come back. I'll be carrying a bunch of flowers. And if the flowers are red, I'm coming to Germany. And if flowers are white, sorry, no go. Thanks for coming. I've made the argument that Einstein delayed his answer to this question, in part because he sort of wanted to live with the pleasure of being so deeply sought after. But it's certainly true that this was not simply a snap decision.
As he often does when he has a difficult problem to solve, Einstein takes a long walk.
Zurich was comfortable. There was lots still up there. You don't just sort of walk away from that.
His wife really wants to stay in Zurich. On the other hand, they've offered him the greatest job imaginable. There was one other thing enticing Einstein to Berlin.
At some point, he received a birthday card. It was Elsa writing him a postcard. This must have exploded on him as, reawakening all these emotions.
Planck and Nernst come back. They're at the train station. Einstein is there. It was a dramatic moment. It was a self-consciously dramatic moment. There would have been a little dramatic flair there. He's holding his flowers. And they look, and the flower is red. Einstein says, gentlemen, I'll go to Germany. I'm going to become one of you.
By April 1914, Einstein's world is looking brighter. The solar eclipse needed to help prove Einstein's long-gestating general theory of relativity is only 4 months away, and Einstein is on his way to Berlin to join the Kaiser Wilhelm Institute, an elite group of scientists working under Fritz Haber, the institute's director.
Fritz Haber was one of the greatest chemists of the 20th century. He developed a process that could be used in producing an artificial fertilizer with the help of which millions could be fed. And he was a hero.
Haber and his family host Einstein's wife, Mileva Maric, while she looks for an apartment for herself, Albert, and their 2 children. Haber observes that resettling in Berlin seems to be unsettling relations between Einstein and his wife.
Mileva always was a brooding and somewhat despondent woman. And in Berlin, it gets much worse. He's dallying with his cousin, Elsa. Einstein is a very brutally honest guy, so every now and then he apparently would tell Mileva about Elsa. Then they start fighting with each other.
Not surprisingly, the man who approaches the universe in a unique way has a rather unconventional approach to married life.
Einstein gives Mileva an ultimatum. If you want to stay married to me, you have to do the following things. It's a contract. It says you have to bring me my meals in my room. You have to speak to me only when I want to have conversation. You're not to expect intimacies from me. More power to her. She doesn't sign this contract. She decides, no, I'm not going to go for that.
She goes and stays again with Haber and his wife Clara. In that time, Haber is sort of a go-between and is negotiating.
He's trying to hold them together. He's the one who keeps seeing if maybe they can come to an accommodation. They both respect him.
But Haber's best efforts to save the Einsteins' marriage are a failure.
The decision to split is finally irrevocable, and Einstein says it's not going to happen.
Lacking enough money to support two households, Einstein makes Mileva a brazenly self-confident proposition.
He offers her a deal. He says to her, one of these days, one of my papers will win the Nobel Prize. If you give me a divorce, I'll give you the money. Now, this is an amazing sum of money. She could end up very wealthy, and she could move back to Zurich with the kids. He is sure he's going to get a Nobel Prize. Mileva's not quite sure. She's a scientist. She calculates the odds. She consults with Fritz Haber. She decides to take the bet. Mileva takes the two young boys, and Einstein accompanies her, along with Fritz Haber.
Einstein has to go to the train station, say goodbye to his boys.
And he starts crying. Haber's never seen him cry before.
This was a really quite devastating moment for him, and Haber was the man he was with, sort of holding him up through this moment.
Einstein has staked his children's future on winning the Nobel Prize, by no means a sure bet. He is dependent on Erwin Freundlich and William Campbell to bring him photos of the total solar eclipse so he can see how the stars seem to move. Shortly before saying goodbye to Mileva and the boys, Einstein has another farewell at the Berlin train station.
There is Freundlich with his two buddies about to leave Berlin. Einstein is there. He's very, very anxious.
Freundlich and two of his colleagues are lugging 4 astronomical cameras and cumbersome equipment on a long and treacherous journey.
They're going to take a train and go all the way to the Crimea in Russian territory.
Freundlich and Campbell hope to maximize their chances of good weather and good eclipse photographs by camping in different sites. Freundlich's party sets up in southeastern Crimea. Campbell locates near Kiev. They are both determined, despite the frightening and spreading rumors of a world war. Then the worst happens. On June 28, 1914, the Archduke Franz Ferdinand of Austria is assassinated. The German Kaiser declares war on Russia, and Einstein's eclipse expeditions are suddenly in jeopardy.
Einstein is really worried.
Einstein has no way to warn them.
Didn't know what was going to happen.
And then, deep in the Crimean forest, the war comes to Freundlich's camp.
Freundlich suddenly sees some uniformed Russian officers coming to his camp and asking him for his papers. Heart starts going, beep, beep, beep.
Russians come over to see what they're doing and realize these are Germans with a telescope.
And they start tearing down his equipment. Get off my equipment. I have to observe an eclipse. These are our possessions now. Your country declared war on us. You have nothing to say.
They arrest them immediately. There's no questions asked, and they are considered spies.
Herr Freundlich, you are now a prisoner of war. What? Campbell, an American, is neutral. And the Russians allowed them to continue to observe the eclipse. They had come all this way, spent all this money, survived the fact that war broke out, and clouds ruined their plans. Total failure.
Not only does Campbell fail to get his photograph, but he is forced to abandon his state-of-the-art equipment. Because he is an American, Campbell is not arrested, but he leaves for home a defeated man.
Campbell says one wants to come home by the back door and see nobody.
Einstein in Berlin is shattered.
The expeditions are failures. Freundlich and his team spend several months as prisoners of war in Russia. For Einstein, it is a disaster. Proof of his most revolutionary theory, general relativity, is slipping between his fingers. The outbreak of World War I leaves Einstein's Russian eclipse expedition in shambles and threatens to further obscure the long-sought proof of the relativity theory on which Einstein has labored for years.
The war killed communication between scientists. The open exchange of ideas was gone overnight.
Ties were cut.
Once the United States joins the war, astronomer William Campbell sees things differently.
Campbell dedicated himself to the eclipse problem, independently of his former colleague from Germany, who he now viewed as the enemy.
In Berlin, the whole atmosphere changed. When Einstein looked out of his window, he would see a lot of patriotism. In his eyes, a whole nation went crazy.
All of Einstein's expectations of the kind of city he was going to live in disappear. They're gone.
Hundreds of thousands of German young men marched enthusiastically.
His best colleagues, Planck and Haber, were enthusiastic about the war.
His close friend Fritz Haber, like Einstein, was born German and Jewish.
Fritz Haber converted to Christianity, and he tried to assimilate as much as possible. One of his great moments of pride when he actually received a commission in the German army. Really almost unheard of award for a converted Jew. Einstein saw this as ridiculous. Haber said, I'm a chemist. I understand the chemistry of the chlorine atom very well. I know that chlorine gas is poisonous. Can I turn this into a useful weapon? Haber felt he could construct a devastating enough weapon that it would end the war quickly, thus a humane outcome.
The institute Haber directs is turned into testing gas to be deployed on the Western Front. Einstein has an office in Haber's institute.
Einstein was disgusted by the eagerness with which Haber, first amongst his colleagues, but many of his colleagues, went looking for ways to kill people and kill them more effectively.
Haber was one of the first to develop terrible weapons out of the potential of science.
Early in the war, Haber's new mystery weapon, poison gas, is tested on a Belgian battlefield.
Haber was there and said, release the weapon. This low cloud drifted over the battlefield, and the cloud just sort of forms. This was the first time this ever happened. Troops had seen things that looked much worse than this cloud, and the effect was devastating. I mean, the troops were just blown out of their trenches.
Haber saw thousands of people die, thousands of soldiers, about 5,000 soldiers.
Your lungs begin to fill with fluid, and as the deterioration of your body continues, you can lie there on dry ground, in effect drowning. Albert Einstein takes a look at his close friend and his, intimate professional colleague and says, in effect, you're pathological. This is grotesque. He writes a letter to a friend in Switzerland that says, all our supposed technological progress is like an axe in the hands of a madman.
Haber never resented it. And it's so strange that he befriended Einstein so closely. They were living on different planets.
The war posed a big dilemma for Einstein because in his personal relationships he respected and was even fond of his colleagues, but rejected their wholehearted support of the war.
He comes across this very publicly hyped and published document called the Manifesto of '93, signed by 93 leading German academics, including the people who brought him to Berlin and the people he most values, Haber, and above all, Max Planck. The manifesto says Germany had to fight, it was justified and morally acceptable to fight in this war. And this shocked Einstein. In effect, a betrayal. This was the moment when Einstein realized that there were some things about life outside physics that were important enough that he had to actually go out on a limb and take some personal risk to defend. He actually tries to present a counter-manifesto of other German academics who say, no, there's something else out there besides national pride, national competitiveness, national fury. And 4 people signed the manifesto. It goes nowhere, never published, it fails.
He becomes a pacifist. He becomes a war resistor.
And Einstein was nearly alone.
He's isolated. He's being rejected by his colleagues. His marriage is breaking up. He's having a custody battle for his kids. He immerses himself in his science.
The isolation has a positive outcome as Einstein looks again at his general relativity theory. He refocuses on the mathematical equations.
One day, he looked back at the calculation for the bending of light as it goes around the sun, and he suddenly realized his earlier calculation was wrong.
What would have been found had Freundlich done the observation was only half the deflection that's there, half the bending of the sunlight.
It would have discredited Einstein's theory.
It is an embarrassing but serendipitous discovery. For 3 years, Einstein has been urging astronomers to photograph an eclipse, which would prove an equation that he now believes to be wrong. Einstein has always considered the failed eclipse expeditions to be setbacks. In fact, they may have saved his career. The war raging all around him, the physicist retreats to his study.
He had a little apartment, and most of his thinking was done in his study.
Sometimes he can't quite visualize the curving of space. And what he does is he takes out his violin. He said that Mozart's music captured the harmonies of the universe. Playing the violin would help him think.
Einstein had this prodigious ability to sit and think. It was called Sitzfleisch. People who knew him said he had this remarkable Sitzfleisch where he can concentrate on a problem for hours, for days, even years.
In his office are lots of mathematical manuscripts with equations all over. And he's sitting there thinking, walking around, standing deep in thought. He's doing pure mathematics in his mind.
Science is done by the seat of your pants. We have leaps of logic. We have years of wandering in the wilderness. We have frustration. We have pulling our hairs out. That is really the power of genius, the force of will to make all the mistakes necessary to get the right answer.
There was never a moment of, oh no, I'm not gonna have a theory. That, because of his ego, I don't think it ever occurred to him that he's not gonna have a theory.
What matters is you keep your eye on the prize.
For Einstein, that prize is the Nobel, proceeds of which he has promised to Mileva and his 2 sons. In 1915, he's asked to present his general theory of relativity at a prestigious forum to the most important German scientists. Einstein accepts. But after 8 years of work, his theory still has 2 major problems. It's completely unproven, and the math appears to be flawed. After nearly a decade of work, Einstein's general theory of relativity is still far from finished. His math is wrong, and without the correct calculation, his theory can't be proven. And now he's scheduled to deliver a paper to the most prestigious scientific gathering in Germany.
Prussian Academy, it's a very formal place. It's a place that knows how distinguished it is and how historically significant it is. These weekly meetings you can sort of see as an attempt by at least some of Germany's leading thinkers to act as if the war were not all there was.
Einstein is to present his theory of general relativity. The problem for Einstein is he hadn't finished it yet.
In the fall of 1915, Einstein was hardly thinking about anything else. He was completely focused on finding the solution to a puzzle that had occupied him for more than 8 years.
Einstein is trying to come up with these equations that describe how space is curved. And he's working deep into the night.
If you look closely, it's really trial and error. You're not seeing a mathematician who just, throws the ideas, perfect formulas onto the paper of the notebook. He cancels everything and says nonsense. These terms disturb. So he's sort of talking to the math. Sometimes he turns the notebook around and then he, throws it away with disgust.
It can be a real blow when an idea you've been working on doesn't work out. This gut-wrenching feeling.
Since discovering his math error, Einstein believes he is making real progress. His equations are nearly complete. He accepts an invitation to speak at Göttingen University, essentially a dress rehearsal for the Prussian Academy.
Einstein is up at the board writing his equations and trying to describe his problem.
In the audience is one of the greatest mathematicians of all time, David Hilbert.
Hilbert sits there and listens very carefully to Einstein. He thinks, I can solve the problem. I can do it better than Einstein.
There's always this worry that you might get scooped. You become a little bit paranoid, or sometimes a lot paranoid. There's always this feeling I have when I have a good idea, which is that, well, if I've had this good idea, that probably means that someone else is going to have or has had this good idea too.
Einstein goes back to Berlin, and Hilbert goes into his own office. And Hilbert sits there and thinks and tries to race Einstein to the big prize of general relativity.
He was one of the greatest mathematicians of his time.
A controversy between the two giants, a giant of physics and a giant of mathematics.
Hilbert, the nasty guy here who thinks he can beat Einstein, starts working.
Hilbert thought that physics was much too important to be left to the physicists, or the mathematicians should take care of it.
Stakes are very high here.
All or nothing. To unlock the secret of light, to unlock the secret of gravity.
Nobody can ever say that Einstein is not a fantastic mathematician, because at that moment, the problem is distilled into pure mathematics.
Several times, Einstein thought he had it. When he submitted one of the versions to the Prussian Academy, he wrote his son in Switzerland, you will later understand that this was a great day that changed history, and your father was, producing it. But it turned out again to be an erroneous version. He had to change it a week later once more. He had tried many alleys before, and they turned out to be dead ends.
How long do you wait developing this idea, writing the paper, working out all the consequences before publishing it?
Einstein had to be really afraid that Hilbert would actually take over the whole game and publish the final equations of general relativity before him. All of a sudden, he discovered that several pointers all seemed to point in the same direction. Einstein remembered that he had given up a very radical solution that he had stumbled upon already in 1912, and that he had then discarded because it looked just physically too unfamiliar, too unacceptable. But now, after he had tried out all these other alternatives, he was ready to return exactly to that equation, back to an equation that he had earlier considered and then discarded 3 years before.
You realize that you've been wrong in a real flash of inspiration because you realized what you should be doing.
He had it all in his drawer.
And that's, of course, then a glorious moment.
There it was, the equation that he had discarded, and now it looked much more promising, much more useful than it had in the winter of 1912.
It isn't always a dark time when you realize that you're wrong. Sometimes it's a wonderful time.
The excitement for Einstein comes with the realization that the answer for his new theory can be found in an old astronomical riddle.
Einstein began to look at a mystery that had puzzled astronomers for generations. According to Isaac Newton, the planet Mercury should be going around the sun like this. But it was known for quite a while that the orbit of Mercury deviates from Newton's laws of motion. It tilts a little bit. So the orbit, instead of going like this, begins to tilt. And it begins to make a pattern like the petals of a flower.
Einstein realizes his thoughts on gravity might explain Mercury's orbit in ways the Newton's law could not.
Was Newton wrong? Einstein says, maybe it's my theory of gravity. Is this simple enough to explain all the experimental data? He calculated painfully the orbit of Mercury, and there was a near perfect match. His equations on a notepad matched the motion of heavenly bodies in outer space. He has heart palpitations, and he suddenly realized, oh my God, the theory is correct.
He was so filled with joy that he couldn't make his brain focus. And for Einstein, that's a big deal.
He finally gets the equations right, just as David Hilbert does. There's a little bit of a dispute. Who got the equations first?
There's a lot of rancor at that moment. Einstein gets so hurt.
Hilbert was very gracious. He says it's Einstein's theory. Einstein deserves the credit.
He's victorious.
The theory is Einstein's.
On November 25th, 1915, a momentarily triumphant Albert Einstein holds in his hands what he believes is the final equation for the general theory of relativity, his theory of gravity, just in time for his presentation at the Prussian Academy.
He goes to the Academy and he speaks. Not for very long. It's a short paper. With that, you have the general theory of relativity, which describes how space and time tell matter and energy where to go. Matter and energy tell space and time how to look. Utterly different view of what our universe is like. Who knows how much applause he got? Nobody does.
Everyone suddenly found themselves confronted with the idea that this strange German Jew had overthrown Newton's ideas of gravity. What exactly this meant now, no one was quite sure.
There's still no physical proof of it.
No one understood Einstein.
Einstein believes he has finally got his theory right, but he knows that it won't be accepted until he can prove it. And he can't prove it without photographs of a total solar eclipse. For that, Einstein will have to wait again. Einstein publishes his completed general theory of relativity in 1916 with a corrected mathematical equation. But there is still much work to be done. He needs photographs of a rare solar eclipse to prove the theory's accuracy. But in war-ravaged Berlin, now under blockade by the British, even the basic necessities of life are hard to come by.
Surrounding him, Berlin was an impoverished city, and the hunger grew so bad that there were hunger riots.
In the middle of a harsh winter, Einstein's intense productivity comes to a sudden halt.
The reason he stops is he's exhausted and he's sick. Bad stomach problems. He's really, really, really sick.
He writes, I don't eat, I haven't been able to sleep, and he succumbs to a physical and a mental breakdown.
Einstein retreats to a small apartment in Berlin. His cousin Elsa becomes his nurse and savior.
Elsa keeps cooking for him, bringing him food, eventually having Einstein move in with her.
While Einstein's health is in Elsa's hands, the fate of his theory lies with astronomers. One of them who will play an important role is at Cambridge University in England. Arthur Eddington is a scientist, but also a religious man who attends this small Quaker meeting house just across the street from the university.
Sitting in the back row at this Quaker meeting, full of people sitting quietly, is Arthur Stanley Eddington, head of the Cambridge Observatory, known all around the world as one of the most brilliant minds in astronomy.
The war has taken a heavy toll on Eddington and his fellow Quakers, nearly all of whom morally opposed the war and refused to fight the Germans.
He's one of the few men left. It's just him and the women. Day by day, men were disappearing from these benches. Not because they were going off to fight in the war, but because they were being arrested for being conscientious objectors.
Anti-German feeling cripples scientific communication. Eddington knows nothing of Einstein's new theory until February 1916, when he receives a package from a colleague in the neutral Netherlands, astronomer Willem de Sitter. Inside is a copy of Einstein's paper that de Sitter has translated into English.
Eddington opens it up and realizes immediately that he's seeing something of tremendous scientific significance.
And he writes back to de Sitter, no one in England knows about this, no one.
So he asks de Sitter, tell me about this Einstein. De Sitter says, well, Einstein didn't like the war and in fact had written a manifesto against the war. And when Eddington hears this, he says, this is perfect. This is so important, we have to do something with it.
The mission becomes more than a scientific quest. Like Einstein, Eddington is isolated because of his political convictions. Eddington sees this exciting scientific challenge as a way to show that scientists across enemy lines can support each other for a higher purpose.
Eddington says, relativity is the most important scientific theory since Newton, and it's done by a German, and even better, Einstein, a brilliant, peaceful scientist. He wanted to stand up there and show the world and show his scientific colleagues that an Englishman will stand up for a German. And the Eclipse expedition was the perfect opportunity.
But the forces of interplanetary alignment may not wait for the war to be over. The next full eclipse will occur in June 1918, and it won't be visible in England, where Eddington is trapped by war. However, it will be seen in the state of Washington, practically in the backyard of a man who has been down this road before, William Wallace Campbell of California's Lick Observatory.
There was going to be another eclipse in 1918, not very far from Lick Observatory in Goldendale, Washington, in the west.
If Campbell succeeds in photographing this eclipse, he can be the first person to determine if Einstein's theory is right or wrong.
Because there was a war going on, no one else could go. The Europeans couldn't send an expedition, and so he had the field to himself.
But Campbell also has a problem.
They didn't have their equipment because it was still trapped in Russia.
Campbell had been forced to abandon his state-of-the-art camera gear in the Crimea back in 1914 when World War I first broke out. So he improvises.
Campbell went scrabbling around for equipment at Lick Observatory. They got a lens here, a tube here, and they cobbled together a couple of cameras for Goldendale.
The Lick party was forced to use substandard equipment.
Campbell has no choice but to take the risk. He has a total solar eclipse all to himself and may never have another opportunity like this again. Campbell's party travels to Goldendale, Washington, and gets ready for the coming eclipse.
It was close to home, so the whole family went.
Campbell's goal is to photograph the stars that emerge in the brief period when the sun is hidden by the moon. But on Saturday, June 8th, 1918, it seems that the universe is once again not ready to yield its secrets.
Clouds moved in, and it looked like he wouldn't even get observations, and Russia would be repeated, which he hated. And suddenly, just at the crucial time, when they needed a clear sky, the clouds parted.
Campbell begins taking photographs of the spectacle.
It starts when the moon first comes in contact with the sun and then starts to move over the face of the sun. The sun becomes smaller and smaller and smaller until the last moment when the sunlight actually passes through the valleys between the mountains of the moon. And then this bright, brilliant beam of sunlight, and then the sun is entirely eclipsed. It's the blackest black you will ever see. My first eclipse, I literally lost my breath. It was like jumping in cold water where you go, you know, you can't believe it. It is breathtaking, literally breathtaking. It's a gorgeous sight.
It's just, wow. Most powerful experience that I've ever had in my life.
The New York Times had a reporter, and they wrote an article, "Clouds Fall Away for Eclipse." There's a little subtitle, "Test of Einstein Theory." This is the first time that an American newspaper mentioned Albert Einstein.
Campbell assigns his most trusted astronomer, Heber D. Curtis, to analyze the photographs to prove or disprove Einstein's theory.
Looking in, a star would have been visible, one of the stars that was to be measured. That star would have been very carefully centered on crosshairs in the eyepiece. Once that was done, the scales could be read in the X and Y directions, and a very precise position could be assigned to the star. From those numbers, it could be determined whether the star had appeared to change position.
Einstein has predicted that the warped space around the sun will create an optical illusion, making the stars appear to move outward ever so slightly.
Einstein predicted much less than a millimeter. This is not an easy measurement to make.
Unlike most theories that people put forth, Einstein's general relativity makes very specific predictions. Very tight, it's gotta be this, and if it's not that, then the entire foundation of the idea has gotta be discarded.
Extremely precise, painstaking measurements.
There was no wiggle room in Einstein's relativity because the idea that gravity is the manifestation of the curvature of space and time. You're going to say how much it curves and what happens to matter or light in the presence of that curvature? Calculate it, make the prediction? If the prediction doesn't come true, you don't go say, okay, let me see if I can tweak the theory. Not in this case.
You can see on these pages the kind of labor that Curtis had to endure in order to make these measurements. There's page after page after page of this. Some pages crossed out.
All you needed was one experiment to show that any aspect of relativity would fail. And he'd have to go back to the drawing board completely.
Curtis looks at the stars and sees nothing unusual. They all appear in their normal places, which can only mean one thing. Einstein is wrong. But Campbell is unwilling to risk his reputation on improvised equipment.
Nobody wants to reveal an answer until everything has been double-checked. The best tactic is total silence until you're absolutely sure what you found.
Campbell orders Curtis to check his results again and again. As Curtis works in quiet isolation atop Mount Hamilton, Europe is in chaos.
The order of Europe changed completely. We have 3 empires that disintegrate within weeks of each other.
On November 9th, 1918, Kaiser Wilhelm abdicates the throne. Einstein notes in his lecture book, class canceled due to revolution. In the immediate aftermath of the war, German scientists, including Einstein, are still not allowed to travel. But Eddington can. Einstein learns that he is going to Africa to photograph a solar eclipse expected on May 29th, 1919.
As Eddington leaves Cambridge, the hallways are full of crutches and canes. Cambridge begins to fill up with students again, but they're crippled or they're maimed. He had no fanfare. He's heading off on a lonely adventure.
Eddington believes in Einstein and hopes to bring back proof of his controversial theory. But in California, astronomer William Campbell is preparing to deliver his own results, and the news appears to be devastating. On two fronts and two continents, the proof of Einstein's theory now hangs in the balance. It's February 1919. Atop Mount Hamilton in California, William Wallace Campbell is examining and re-examining photographic plates which appear to indicate that Einstein's general theory of relativity, his theory of gravity, is wrong. But Campbell has competition from British astronomer Arthur Eddington, who is on his way to photograph an eclipse in Africa.
Eddington leaves Britain and heads south.
He's in his late 30s. Travel in those days was not comfortable. This is the tropics, the height of summer. It must have been a very unpleasant place to be.
In May of 1919, after 10 weeks at sea, Eddington and his assistant arrive on the shores of Principe, a small island off the coast of West Africa.
Malaria is a big problem. There are poisonous snakes. He has to hack his way through the jungle.
They spend a month building a telescope in the middle of the jungle. The day of the eclipse, rain is coming rolling down. He's crushed.
Phenomenal disappointment. But then suddenly, amazingly, a gap in the clouds. He sees a black moon.
They have to begin taking photographs right then. They just start the device, the mirror begins to rotate, and then you put a photographic plate in the end of the telescope.
It holds the film, and that plate has to be held with the telescope. Everything has to be aligned correctly.
Take out a new photographic plate, put it in. Take it out, put a new photographic plate in, and you try to get as many as you can.
Tremendous race, but let's keep calm. Let's maintain composure. There's a great tendency to leave the lens cap on, to get the exposure incorrect, to make a fundamental error that would then ruin your career.
Time is ticking away, the precious seconds. He doesn't really care about the sky going dark. He's looking for the star that's right there by the sun, grazing the sun.
He's so busy working the telescope and switching out the photographic plates that, as he says it, he just had to do it in faith.
He basically had to trust that something was going to appear on his plates.
Like Campbell before him, Eddington is in for a crushing disappointment.
He quickly discovered that most of his plates were worthless.
The clouds have obscured nearly all the stars on every single photograph.
But the very last few plates had just a few stars, which gave him some encouragement that he was going to be able to salvage something.
You can imagine Eddington in this remote island, sitting down with a micrometer, a measuring machine, and looking, this distinguished theorist looking at these plates. His discipline is phenomenal.
Now, to make these measurements, it's difficult. We're sitting here under this thick layer of atmosphere. Light comes from the distant reaches of the universe, and then it gets like jiggled and wiggled and smeared as it gets through the atmosphere. And by the time you're looking at starlight, which should be a pristine point of light, it's this smudge. It's a smudge.
It would quickly become apparent that it was going to be a much, much more difficult job.
They're doing these precise measurements in the middle of the jungle.
He can't wait to get back to Britain. Of course, it's going to take him months to get back.
Einstein was waiting very anxiously. He was getting a lot of letters from friends and colleagues asking if any news was afoot. But relations between England and Germany were very, very frosty, and Einstein didn't think it would be at all appropriate for him to presume to write to one of these English astronomers and ask them what was going on.
Eddington returns to Cambridge Observatory just as Campbell sails into London. Campbell is here to address the Royal Astronomical Society, an organization dating back to the age of Isaac Newton. He carries with him the secret results of his eclipse expedition of the year before.
Campbell is the first to speak, and he was nervous because there were a lot of emotions flying about this test and a lot of reputations at stake.
The anxiety must have been enormous because he's in front of all of his colleagues.
There is that one moment, the one moment that you stand before your peers.
I don't think you ever really feel ready.
Butterflies.
And then finally, Campbell announces his results.
He said Einstein is wrong, and Lick Observatory says Einstein is wrong.
But the session takes a dramatic turn with the reading of a cable from Eddington. His preliminary findings show just the opposite.
The British were going to say that Einstein's right. Eddington still had more calculations to do, and it wouldn't be ready for a couple of months. But here we have this special meeting of the Royal Astronomical Society. Everyone's watching. Campbell says Einstein's wrong. The British say, we don't know yet, but it looks like he might be right. Having just delivered a death blow to Einstein, Campbell started to really get nervous sitting in that room.
Campbell sends an urgent message to his colleagues back in America, who were about to release their negative report on the eclipse photos. It was an historic cable of 5 words.
Delay publishing Einstein results, Campbell.
4 months later, on November 6, 1919, Eddington travels from Cambridge to London to address the Royal Astronomical Society. He has finalized his photographic findings on Einstein's theory.
People come down from all over England to see what's going to happen.
Everybody is shoving their way in there so they can see what the results are going to be. The portrait of Newton overlooking the whole ceremony.
Had Newton been able to look down on this meeting, I think he would have been absolutely fascinated.
Eddington begins the meeting by pointing to the portrait of the founder of the Royal Society and saying, "Forgive us, Sir Isaac Newton, your universe has been overturned."
The eclipse was partially obscured by clouds, but a few photographs of value were obtained.
The secretary of the society records Eddington's results.
The measurements of the plates have led to the conclusion that the deflection of 1 second .75 at the sun's limb, predicted by Einstein's general theory of relativity, is verified by the eclipse observations.
The public interest that gets generated by this is tremendous.
Outside of the scientific community, no one had even heard of Albert Einstein, let alone his bizarre theories. Now the public learns that everything they believe about the universe is wrong.
The Times of London says, in effect, there is a whole new theory of the world. Ideas we've known for hundreds of years are wrong, and this man, this German scientist, Albert Einstein, has given us a new truth.
The New York Times has one of the greatest headlines. Men of science more or less agog over eclipse observations. Einstein theory triumphs.
And it is then that the German press also picks up on these events.
There's a Berlin magazine that shows him, sort of this romantic face with a already fairly, dramatic hair, and this faraway look in his eyes. And the caption to the cover of this magazine says, a new figure in world history.
Although few people really understand Einstein's ideas, soon everyone knows his name.
Beers are named after him. Mothers named some of their children after him. Einstein himself never realized that his obscure theory of gravity would excite the public imagination.
He says things are crazy here with the press. They all want an article, they want a lecture, they want photographs. It is all a craziness.
This is, one of the first great ages of photography. There are pictures of Einstein. There are undersea cables. People can carry news all over the world. There are newsreels. You can see the man moving and talking.
Without such freedom, there would have been no Shakespeare, no Goethe, no Newton, no Faraday, no Pasteur, and no Leibniz.
But despite the public adulation, scientists still have their doubts about his theory.
People are making a mistake. They're mistaking Einstein's fame for acceptance of his theory. They're equating the two, and that's very far from what happened.
A backlash set in. In the New York Times, you can see that they were constantly questioning, who is this famous scientist?
Most British people and most Americans, most people from the Allied powers were very hostile to Germany after the war. They were not at all interested in reconciliation. So many people were saying, oh, Eddington was so motivated by the goal of peace and promoting international brotherhood. He was so convinced by the theory that perhaps
He allowed himself to be a little bit biased.
He's been criticized for fudging the figures.
The photographic results from the two solar eclipse expeditions, Eddington's and Campbell's, result in a split decision. Another expedition will need to be mounted. Both Einstein, who has been trying to prove his theory since he first proposed it in 1907, and Campbell, who has been working on the problem since 1911, have tremendous personal stakes in the results.
Now it was a matter of not just science, it was a matter of international reputation, it was a matter of personal reputation. This was personal.
Campbell checks the charts and sees that the next best eclipse to photograph will be in Australia in 1922, more than 2 years from now. And it turns out, he will not be the only one to take up the challenge. It's 1921, and the 42-year-old Albert Einstein becomes science's first superstar.
Einstein has this sort of victory tour of the world.
In America, the newspapers are reporting as the boat goes across the Atlantic, Einstein is coming. There are 15,000 people waiting to meet Einstein in Lower Manhattan. This is for a theoretical physicist. He traveled all up and down the East Coast, through the Midwest. Einstein is a total phenomenon.
But more importantly for Einstein, the scientific community is still debating whether his theory is correct. And the more attention Einstein gets, the more his theory is thrown into doubt.
Einstein is being exposed to increasing criticism of his theory of relativity.
People said, we have to redo the test.
In September of 1922, a total solar eclipse will be fully visible in Australia, and William Wallace Campbell sees an opportunity to set things right once and for all.
He started making plans to completely redo his equipment.
Completely redesigned entirely with this measurement in mind. This was the Cadillac of Einstein effect measuring equipment.
The first eclipse point was the very, very, very westernmost part of Australia, in a place called 90 Mile Beach.
But this time, Campbell is not the only one pursuing this goal.
7, count them, 7 expeditions went to Australia. The British sent an expedition. Freundlich led an expedition. It was the first time he had a chance since Russia. John Evershed, a British astronomer, was able to come from India. The Canadians sent an expedition, and 2 Australian expeditions went. Serious competition to Campbell. The British and Freundlich got clouded out. One of the Australians couldn't get any data. Their equipment was lousy. Poor Evershed from India had beautiful clear skies, but he had technical difficulties, so he got nothing.
Campbell, now in his 3rd expedition, is much better prepared. He gets perfect results.
And they showed, I think, 92 stars that the Einstein effect was not only there, but it behaved as Einstein predicted, very clearly, very unambiguously. This is one of the lenses which confirmed the theory of relativity. The light actually passed through this lens and actually fell on this plate. This stuff is way cool. I mean, this is the heart. The stars that could be seen around the eclipsed sun, here highlighted, showed just the deflection predicted by relativity.
They nailed it. Einstein was so right.
It is a proud personal achievement for Campbell and a landmark moment for science.
The Lick Party finally succeeds, gets extraordinarily good results, and resoundingly corroborates Eddington's 1919 measurements.
Now, who was the first person that Campbell sent a cable to with the result? Albert Einstein. He wanted Einstein to know, boy, did we vindicate you. Boy, did we show that Eddington was right, despite what all the scoffers are saying. For Einstein, this was a tremendous triumph.
The eclipse expedition gives us amazing proof of something that looks theoretical, and yet it's very much part of our lives.
They showed that space-time around the sun was curving.
It was a whole new way of thinking about how gravity works.
How strange is that? That's completely against our intuition. But it's what the data showed. And you cannot argue with the data. Nature agrees. Yes, Einstein, that's a beautiful theory. You're right.
Finally, 15 years after he first proposed his radical general theory of relativity, upending more than 2 centuries of scientific thought, Einstein is victorious and vindicated. Almost.
The Nobel Committee rejected him in 1919 and in 1920 and in 1921 because no one accepted the theory of relativity.
Einstein had promised the money from the prize as part of his divorce from Mileva and his support for his 2 sons.
Mileva has resigned to the divorce, living with the boys in Zurich, waiting for the money from the Nobel Prize to come her way. She's actually relying on it.
Now, it's not until 1922 that they finally announce his Nobel Prize. And one of the ironies, he never gets it for the theory of relativity.
Instead, Einstein receives it for the first of his Miracle Year papers, which describes the photoelectric effect. This work becomes the foundation for quantum mechanics and unlocks the secrets of the atom. To Einstein's former wife, Mileva, the prize means something more down to earth.
She gets the money and she ends up buying 3 apartment buildings in Zurich.
Mileva did not make a very good living from these investments, but she survived.
For Einstein's cousin Elsa, who has nursed him through the bad times and waited patiently for years, there is also a victory of sorts.
She has convinced Einstein to marry her. Great surprise. It was a strange marriage. Einstein had many lovers afterwards, and he never felt that this was sort of, the perfect way of life for him.
But she loved being Mrs. Einstein. She loved traveling with him. She loved the prestige and the glory that came from being his wife.
As the world recovers from a horrific war, it embraces a man with the obscure occupation of theoretical physicist and turns him into a global icon.
Here you have the end of the most destructive war in European memory.
And here this pacifist saint comes along with a wild halo of hair, piercing eyes, and people on all sides of the Atlantic, in Germany and in England and in America, could all celebrate him as a man of peace, but also somebody whose science transcended the horrors of war.
That's where the emotional resonance of his accomplishment came, I think. And that's why people seized on him, not just as a smart guy, but as a symbol, maybe an all-purpose symbol of what humanity can do well in the context of what humanity has clearly done so terribly.
His story, the solo scientist who turns the world upside down, is enticing. Alone in his studio, using only his mind and a pencil, Einstein made bizarre discoveries as intriguing to the public as the most talked about music and movies of the day.
They loved the mystery. Einstein himself said so. The fact that there are these wonderful words of the 4th dimension, bending of space, time warps, all that kind of thing. It's great. Light moves in ways you don't expect. These are kind of romantic ideas. These are, mind-bending ideas, and people picked up on them in all kinds of ways. And it had this cool quality to it.
He could see in ways that no one else could. He put together elements of the universe that others had not imagined would fit together. The general theory of relativity is one of the greatest achievements of the human mind.
If you think about it, the entire modern age, the age of laser beams, telecommunications, satellites, that age was opened up by the work of Albert Einstein. For example, black holes and neutron stars and the Big Bang itself. You cannot describe them adequately without Einstein's theory of general relativity.
It is beautiful and simple and profound. And all the best theories of the universe are just that.
Einstein dies in 1955 at the age of 76. But more than a half a century later, the man and his theories continue to capture the popular imagination and to inspire.
Here was a man, because of the power of his intellect, the sheer power of his mind, was able to rise above poverty, rise above war and strife, to become one of the great figures in all of human history. And that was an inspiration, because you don't have to be born handsome. You don't have to be born with muscles. You don't have to be born that way. You can achieve it by the sheer power of intellect. And for me, that's always been a shining beacon.